So this is the second part of the video on ellipses. Make sure you've watched part 1 before continuing with this video. Let's review what we learned in the first video. The standard form for the ellipse will look like either this or this, depending on the direction of the ellipse. Knowing that A must be bigger than B, if the larger value is underneath the x, the ellipse will look like that first equation. However, if the larger value is underneath the y, it'll be the second form of our equation. Okay, keeping in mind, the largest denominator we always call the a value. Now the center of either one of these is again hk, but it's the direction of the major axes and where the foci are going to be that changes with the equation. If the larger value is underneath the x, the direction of the major axis is horizontal. It runs side to side. Whereas if it is underneath the y value, then the ellipse is vertical, and it's going to be stretched more vertically. Again, notice it's under what value, either x or y, the greater piece is, in which in this case we're going to call the a. Now the foci also will change depending on the equation. If the foci is more stretched horizontally, you're going to add it to the h value of the center hk, or subtract it. And if it's more stretched vertically, then you're going to be adding and subtracting the c value to the k in the center hk. Now again, the way I'm setting this up, I always say the larger value is a, so the length of the major axis is always 2a, and the length of the minor axis is always 2b, which is the smaller of the two values. Now in this video, we're going to look at, given the graph, how do we come up with the equation and the location of the foci. So let's take a look. Here I've got a graph of an ellipse already drawn. What do you notice? Well, the center I can see. If we look at those extreme values left and right and up and down, if we put the, connect them, we would find out where the center is. The center is going to be right here. And that's going to be -3, -1. Now, which one is the larger of the axes of symmetry? That's going to become the major axis. Because this ellipse is more stretched vertically, the major axis is that y or vertical axis. Looking at it, we can see how long it's going to be in both directions, 4 up and 4 down, which I'm going to use to find the a value. A is 4. It is only 1 unit to the right and left of center, which means the b value is just 1. Now we can use this to start writing the equation. We know that it should be x minus h. H is a -3, so this becomes the quantity x plus 3 squared over. Plus, y minus k squared would become y plus 1 quantity squared over equals 1. But what about the denominators? Where does a squared go? A squared is going to go underneath the y value because this ellipse is more stretched vertically. The major axis is a vertical axis. Therefore, and again, remember it's not 4, it's going to be the a squared, which is going to be 4 squared. And underneath the x, we're going to have the b squared, which is going to be 1 squared. Rewriting this, we're going to get the quantity x plus 3 squared over 1, plus the quantity y plus 1 squared over 16 is equal to 1. And that's going to be the equation for this ellipse. Now, but what about where the foci are? We know that the ellipse is more stretched vertically, which means we're going to be adding it and subtracting it to the k value in our center, -3, -1. But what are we going to add or subtract? We need to find the c value first. Using our equation, c squared equals a squared minus b squared, and substituting in those a and b values, we would get root 15, or about 3.87. Now again, because this ellipse is more stretched vertically, we need to add or subtract that to the k value. So we're going to get -3, -1 plus or minus that 3.87. Or, one of the focus is at -3, 2.87, and the other focus is at -3, -4.87. One's above the center and one's below the center, again because this ellipse is more stretched vertically. Let's try another example. Now this one, there's a couple things going on. Take a look at it for a minute and see, what do you notice? Well, hopefully you figured out where the center is. It's at 0, 0. We can look and see that it is more stretched vertically again. So the major axis again is the y-axis. And counting, we can see that it's going to be 6 units above or 6 units below. That's going to be the a value. And that's again because those extreme up and down values are going to be 0, 6, and 0, -6 with the center at 0, 0. But what about the b value? How long is the minor axis? Well, that's a problem. It's in between, and we don't know what that actual value is going to be. How do we find it? Well, I actually see where the focus is, so maybe I need to do that instead. In this case, normally I'd be solved for the focus, but the focus is actually marked. We can see that the C value is 3 units above center and 3 units below center. So we actually know the C value and the A value, but not the B value this time. Well, we can still use our equation and we can still solve for it. We know that C squared equals A squared minus B squared, and we know where the foci are. We know what the major axis is, so let's substitute this in. We know that the C squared is going to become 3 squared equals, we know that A is 6, so that's 6 squared, and we can use this to solve for what the B is. Squaring those values, we get 9 equals 36 minus B squared. Subtracting 36 from both sides, we get negative 27 equals negative B squared. Don't panic, we can still divide by negative 1 and get a positive value here. B squared equals 27, or B equals the square root of 27, or approximately 5.20. Okay, knowing that B is root 27, or again, approximately 5.20, and if we look at the graph, that should make sense. It is in between 5.0 and 6.0, closer to the 5, so 5.20 is reasonable. We're now ready to write the equation. Now, because this ellipse is more stretched vertically, we're going to keep that in mind when we write our equation. We know that it's x squared over something plus y squared over something that equals 1. All ellipses are equal to 1. But where does the a value go? Again, as I just said, because this ellipse is more stretched vertically, we know that a value has to go under the y squared. Keeping in mind, though, it should be a squared down below. In this case, 6 squared. What do we put underneath the x? Well, it should be b squared, which is going to be root 27 squared. Don't panic, because that's just going to become 27. We get x squared over 27 plus y squared over 36 equals 1. It's actually kind of easier having that radical because the square and the square root just cancel. Well, let's try one more example and have you do it this time. Here's another problem I want you to work out. Go ahead and pause this video, work this one out, and when you're ready, resume the video to check your answers. I'll give you a moment. All right, hopefully you've worked this one out. Now this one is going to be centered at 0, 0 also. Not all of these that we're going to do are centered at 0, 0, but this one is. The major axis is going to be the x-axis because moving to the right of center of 3 is going to be greater than moving up to 2. So A is going to be 3, and the B is going to be 2. We know that it's going to be x squared over plus y squared over that equals 1. Now again, it's x squared and y squared, nothing added or subtracted because the center is 0, 0. Now let's find where we're going to put the a and b values. Where does a squared go? Well, because this ellipse is more stretched horizontally, or it has the x-axis for the major axis, we're going to go ahead and put the greater value underneath the x. So in this case, 3 squared goes underneath the x, and the 2 squared goes underneath the y. So this equation becomes x squared over 9 plus y squared over 4 is equal to 1. Now let's turn our attention to where the foci are. Using the equation c squared equals a squared minus b squared, and substituting in, c squared equals 9 minus 4, or c equals root 5. Now that's about 2.24. Because this ellipse, again, is stretched horizontally more, we know that we're going to be adding this to the h values and subtracting. So this will be 0 plus or minus 2.24 comma 0, or negative 2.240 and positive 2.240. All right, thank you for watching this video. I am going to attach the link to the handout for this inside the notes. So if you look at the comment section, there hopefully we'll have the link to the video there, or to the notes. All right, thank you for watching.